All right, welcome back again into the next segment. We're looking at question number 5. We're still doing a grade 12 June examination question paper. We are now in question 5. We're looking at finance, and now we're going to start with 5.1 finance. They say that a steam in a boiler was heated up to 150, was heated to 150 degrees and then allowed it to cool. Its temperature in Celsius degrees was recorded each time as shown in the following table. So this is the time that we have from 0 to 5, and then this is the temperature we have from 150, and it is cooling all the way down to 130,8. Now the question says determine the rate of depreciation. Hint, use the first and the last wheel. All right, let's answer this one. So the formula that we're going to use is given by a equals to p y minus I all to the exponent of n. We're going to determine the rate of depreciation. When we determine the rate of depreciation, it simply means that we are solving for I. Okay, now let's collect our data. We have AP, we have I, and then we have n. Okay, very important that you know your data so that you can substitute appropriately. So in this case, A represents our future. The after the temperature has cooled down, how much do we have left? So we have 130,8. Presently, where do we start? We start at 150 degrees. These are in degrees, and then this is what we are calculating. So I'm just going to put an n. So this thing, it is depreciating over how long? Over 5 minutes over there. So that means the value of n here is 5. So immediately after collecting the data, and then we do our substitution, where we see a, we're going to put in 130,8. This is equals to p, which is 150. 1 minus I all the way to the exponent of 5. Why am I using a negative? Because of it is depreciating. So when something depreciates, we are using a negative sign. We are subtracting. Okay. So first thing first, I'm going to divide both sides by 150. Also this side you're going to divide by 150. These two are going to cancel, so I'll be left with 1 minus I to the exponent of 5. This is going to be 130,8 all divided by 150. Just leave it as it is, do not round it off. And then we want to get rid of this 5, so we're going to introduce the fifth root. Also here you're going to introduce the fifth root. So the fifth root is going to divide with this 5, so I'll be left with 1 minus I. This is going to be equal to the fifth root of 130,8 all divided by 150, and then I am going to subtract 1 on both sides, so negative I in this case. I'll be left with the fifth root of 130,8 all divided by 150, and then if you subtract 1, it's going to have negative 1 there. Therefore my I, if you divide everything or just put everything into your calculator, especially this part, let's just say we have negative I. Let me put it as negative I on this side. So if you have negative I, this is going to be, put the whole thing into your calculator, write down all the decimal numbers, do not round them off yet until you get to the final answer. So the answer here is going to be negative 0,02 70 and then 2138, and then you can divide both sides by negative, which is going to be the positive value of this 0,02702138 on your calculator. So this is your I. We need to calculate the rate, so you multiply this by 100. Therefore R, small letter r, small letter r there, it is equals to 2,70%. Just use your calculator here. use your calculator here so that you can get to this. Use your calculator. Multiplying by 100, use your calculator accordingly, and then that is how we answer 5.1. Great. All right, let's move on to 5.2. 5.2, it says that the nominal effective interest rate charged on an investment is 12.5% compounded quarterly. Calculate the nominal interest rate of the investment. Okay, let's see how do we calculate this one. The formula is in the formula sheet. This is the formula you're going to use. It is equals to, open bracket, 1 plus I divided by m, all to the exponent of m minus 1. Then you do your substitution. First and first, you're going to convert this to decimal. So 12,5, you divide that by 100. When you divide it by 100, it's 0,125. You divide it by 100 and then becomes 0,125. Okay, so the one that you see on the left here, it is your effective interest rate. I normally like to write it like this and say I, and then you put an EFF there to represent your effective interest rate. And then the one that is inside here, normally how I like to write it, I put INOM, representing the nominal interest rate, so that we do not get confused. So this is what we have. It is our effective interest rate. So you're going to substitute 0,125. It is equals to, open bracket, 1 plus IN. You just put an IN. They say it is compounded quarterly. When it's compounded quarterly, it means that you're going to have to divide that by 4. And then you're going to raise that to the exponent of 4, and then you minus 1. Okay, take the 1 to the other side. You are going to add it. 0,125 plus 1, it is equals to 1 plus IN divided by 4, all to the exponent of 4. When you add 1 to this, it becomes 1,125, which is equals to 1 plus IN divided by 4, all to the exponent of 4. So we need to get rid of this 4. So you can multiply this by 1 over 4. What you do on the left, you must also do it on the right. So it means that also on the side, I'm going to multiply or raise it to the exponent of 1 over 4. Where 4 and 4, they divide, then I'm left with 1 plus IN divided by 4. And then that means on the other side here, I am left with 1 plus, not 1 plus, 1 comma, yes, 1,125, all to the exponent of 1 over 4. And then you transpose 1 to the other side. So IN divided by 4, this is going to be 1,125 to the exponent of 1 over 4 minus 1. And then you multiply everything by 4. Just put it up there. You multiply everything by 4. So on the left hand side, you'll be left with your nominal interest rate. It is equals to everything multiplied by 4. So it's going to be 4 into, open bracket, 1,125, all to the exponent of 1 over 4 minus 1. Close the bracket. You put the whole thing inside your calculator. So your nominal interest is going to give us 0,1195, and then you multiply this by 100, so you can get that rate, which is going to be 11.95%. Remember, guys, in finance you only round off once you get to the final answer. Here, guys, what I did here, just if you do not understand, you can use the fourth root as well. You can introduce the fourth root. By introducing the fourth root here, what I mean is that on the left hand side, instead of having 1,125 to the exponent of 1 over 4, you can have the fourth root of 1,125. This is what you can work with up until you can continue to write this like this until you get here, and also on this part. Then you minus 1 and then you get to the final answer there. So that is our 5.2. Okay. Let's look at 5.3. 5.3, they say that Mr. Kasim invested 4,800 rand in a savings account that offers the following: an interest rate of 8.15 per annum compounded monthly, an amount of 1,200 rand. It was withdrawn from the account at the end of the first year. Calculate the total amount of the money that will be in the account after 5 years. Okay, let's see how we have done this. Okay, there are two ways that we can do this. We can calculate the money for 5 years, and then after 5 years, and then we subtract the money for 4 years, because it was only withdrawn once. Or we can calculate the money for the first year. After calculating the money for the first year, and then we withdraw the 1,200 rand, use the amount and then calculate it for the remaining number of years. So I'm gonna go with the second option. It makes more sense. Okay, now here's what we have. We've got the formula that we're going to use is this one here: a equals to p 1 plus I all to the exponent of n, and then the amount that we have, it is 4,800 rand into 1 plus, how much is the interest? It's 8,15. That 8,15, you're going to convert it. So 8,15 you divided by 100, it is going to give us 0,0815. 0,0815. So that is the amount of money that the converted interest rate. And then you're going to substitute that one here, 0,0815, and then you divide it by, remember it is compounded monthly. Monthly, it means that you divide it by 12, all to the exponent of, let's calculate for the first year, 1 multiplied by 12. You put the whole thing inside your calculator. For the first year, you're going to have 5,206 comma 148,882, and then we withdrew 1,200, so we minus 1,200 here, and then what do we have left? We have 4,006 comma 14882. Now this is the money we have after withdrawal, ne? So the money that we have after withdrawal, then we're going to calculate the amount of money that we have for the remaining number of years. We're going to calculate the money that we have for the remaining number of years. So in this case, so this one will become our new A. So we had this A, and then this one will become our new A there. So therefore, that means P, actually. This is going to become our new P. Let's call this one P2. So therefore, A is equals to P2 into 1 plus I all to the exponent of n. So I'm going to use this amount of money here, 4,006 comma 148,882 open bracket 1 plus our interest rate. It did not change, so we're still going to use the same 0,0815. You divide this by 12, it's still compounded, and then we withdrew. So how many number of years do we have left? We have four number of years left, because this is just only for 1 year. We have 4 number of years left. We're going to multiply this by 12, And then our final answer is going to be 5,544.07. So that's how much we do have. Let me put an R there to indicate that we are dealing with money here. So that is the value of A after 5 years. Let's see what we can do with question number 6. Bye-bye.